All right, in the bell work, we were just reviewing learning target 8 or 7. It could be graphing, but we need to solve the system of equations. When I see y equals 2x in the first one, I think substitution. Hopefully you see that, and that's what you're thinking. So you substitute, and you get x plus 2x equals 5,100. You get 3x equals 5,100. You divide by 3, and help me out there, 1,700. Okay. And then you plug it back into either of the originals. I like the second one where you double the 1,700, and it gives you 3,400. So y is 3,400. That's an ordered pair. We're going to need it in the first problem. Okay, number 2, x is 500. We know that. So to get y, you double it according to the second equation. So plug it in. When you double that 500, you get the ordered pair 500 comma 1,000. And last, again, x is 500. So plug that in to the second equation and ask yourself, what do you add to 500 to make 5,100? 4,600, right? All right, so we've got those. Now comes the tricky part. Our learning target 11 is just solving linear programming problems that are real-world problems. So they won't give you a system of inequalities. They won't give you a profit or cost function to maximize. You're going to have to write them all from scratch, from a word problem. All right, so read it with me if you want. Read along. I'm going to read it aloud. First problem. It's kind of like the RSEC. Well, it's not called the RSEC anymore. It's the CFSB Center. It's a college arena. They sell tickets for concerts, for basketball games, and they want to make money from it. All right, so in this one, a college arena sells tickets to students and to the public. Students are sold for $10, public for $15. The college wants to sell at least 500 student tickets and at least twice as many public tickets as student tickets. The arena seats a total of 5,100. How many student and public tickets should they sell to maximize profit? What is the maximum profit? You could trial and error until you maybe figured it all out, but it would be a lot of trial and error. The way to get this answer for sure is to take all of those limiting sentences, like at least 500, at least twice as many, and write inequalities. Those are greater thans or less thans. Graph them all, you'll have a feasible region, and then plug in the corners. That's what this is. All right? So now, there's a step-by-step direction here, this box, that I'm going to be using with the template you have. But I've got it all on one page. So I just copied the word problem over, okay? And that's the template you have. First step is you got to define your variables. What's going to be x and what's going to be y? The place to look for that is at the bottom where they ask the question. How many students and how many public? That's your variables. Just to be consistent, let's all go with x being the number of student tickets and y being the number of public tickets. That's step 1. Step 2 says to start writing inequalities and your profit function. But what you have to do is probably reread the problem several times. Not the whole thing, but scan it for any phrase that sounds like a restriction. So scan that problem for the first phrase you find that sounds like a restriction. At least 500 is the first one that I see. All right? Some of you, this is where it kind of gets differentiated. Some of you can take that phrase and you already know what to write as your algebraic inequality. But do you remember, Wednesday, when we did the concrete example on the board? That's what that was for. So if you struggle with taking those words and turning it into x is greater than or equal to 500, use a concrete example, okay? We're going to use it on the next phrase. But for this one, I think we can all kind of see at least, the phrase is at least 500 student. And that turns into an inequality of x is greater than or equal to 500. I think that one feels okay, right? That one feels right. The number of tickets x that you sell for students has to be at least 500. The next phrase that we come across, at least twice as many public tickets as students. This is where it gets tricky. This is where it gets tricky. because your brain is probably going to tell you to multiply 2 by something, but which one is it? This is where concrete example helps. I'm going to just throw out 2 numbers. An example, 1,000 for X, 3,000 for Y. Does that situation, that example, I call it a concrete example, does it work? Oh, you're already shaking your head, yes. What did you do with the numbers to test to see if it worked? What did you do with the 1,000 and the 3,000? Yeah, you multiplied the 1,000 by 2. So I'm just going to write that down. 2 times 1,000. And then you checked to see if 3,000 was bigger than that. Agree? So 3,000 goes over here. Is it bigger or equal to that? And when you write a 3,000, you're writing a Y. When you're writing a 1,000, you're writing an X. So you've just written your equations, your inequality, sorry. The 3,000 is Y, the 1,000 is X. All right, and I don't want this recording to take too long and your notes to take too long, but the phrase, at least twice as many, blah, 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 blah. That's the phrase. Translates into what algebraic inequality? Y is greater than or equal to 2x. Y is greater than or equal to 2x. Now, why is that possibly confusing? Because the words, when you read the sentence, it says twice as many public. And the tendency I get is that people will multiply the Y by 2. Because the words say twice as many public. And the public is Y, right? So just be careful with that. Be careful with the wording. Twice as many public doesn't mean you double the public. In fact, public is supposed to be bigger. You double the smaller. Anyways, moving on. There's one more phrase. At least 5,100. So we've got a concrete example. 1,000 and 3,000. Does it work? Yeah, and what did you do with the numbers to figure out if it worked? You added them up, and you checked to see if it's smaller than 5,100, right? So that looks like 1,000 plus 3,000. Is it less than or equal to 5,100? As soon as you think like that, you've already written your inequality. Your inequality is x plus y is less than or equal to 5,100. All right, so the phrase, what was it? Okay, total of 5,100. You can be, more, you can write your phrases here or not. I just want to illustrate that you look for those phrases. And the inequality is x plus y less than or equal to 5,100. All right, now I'm going to go back through because it's starting to get messy, and I'm crossing out all this stuff I've already used to see what's left. What have I not addressed? Are there any other phrases that limit how many people can come to the arena? Now we've covered them all. There is still information, but it's about money, right? That's going to be your objective function. It's going to deal with your profit, whether you maximize profit or minimize costs. Okay, and concrete example, again, will help here. How much money do you make with that 1,000 and 3,000? Aren't you going to take the 1,000 student tickets and multiply them by 10? And the public take that 3,000 and multiply it by 15? So the profit function, the phrase, has to do with $10 and $15. The function is $10 for each student, so 10x plus 15y. Now you've used all the information. You've got your inequalities to graph. You've got your profit function. But the thing that we forget the most, I just forgot it and forgot to address it, and I'm just now remembering it. Logical. Can you sell a negative number of tickets? No. Well, let's think. X is bigger than 0. Isn't there already an inequality on the table that talks about X being bigger than 0? It already says X is bigger than 500. We don't need X is greater than or equal to 0. But it doesn't say anything about Y being greater than or equal to 0, so we will need the logical. Y is greater than or equal to 0. And we will graph these 4 inequalities onto a graph. That's why you've got the extra piece of graph paper. And then you're going to look at the feasible region and maximize this profit. and make the CFSB Center the most money they can with this amount. And it kind of makes sense. They want twice as many public as students, so they want to have a student section, but they want more publics coming to the games. It's just kind of a realistic example. All right, now before you start labeling things on your graph, you're always going to be in the first quadrant. When you're in the real world, you're not going to sell negative number, right? You're never going to be in the negatives on the XY axis. So all you're going to need is kind of a T that looks like that on all your graphs. But you need to decide what to count by. Before you make that decision, put everything in slope-intercept form, ready to graph, and then we'll make that decision. I think we only have to do that to one inequality. This one right here, we need to subtract the x. I'll go ahead and label I need to move that over, it's going to get in the way. I'll go ahead and label the x-axis and the y-axis what they are. X is student, y is public. So student tickets. The y-axis is public tickets. And then think about graphing a 500, an x value, 500. Think about graphing a 5100. What might be appropriate to count by? 100s would be nice. 100s would be nice, but how many 100s would you need to get to 5100? 51. You'd need the whole page to graph. All right? So probably not going to be appropriate to count by 100s. Maybe 500s, maybe 1000s. That's a decision you'll have to make. Okay? I'm going to go with 500s, I think. Yeah, I'm going to count by 500s, but I'm only going to label by thousands because I'm going to be lazy with it. Just going to count by 500s, but label by thousands. So that would look like this. Skip one, label 1,000. Skip one, label 2,000. 3,000. Skip one, 4,000. 5,000. 6,000. 7,000. You could keep labeling, but we're not going to need any more than that. And I'm going to label the same thing on the x-axis for this reason. If you change what you count by, you have to really think about your slope. If you count by the same thing, and the slope is -1, you just go down one, right one. So I'm going to count by the same thing, 500. So I'm going to label every other with 1,000, 2,000, 3,000, and so forth. You can already start to tell how long this is taking, right, to do one problem. It's just a lot to think about. I'm not giving you a whole lot of homework. I think there's only like 8. And I'm giving you Monday to work on them in class too, and me to help with you, okay? All right, now we start graphing. X is greater than or equal to 500. Solid line at 500. Shade right. Now I'm going to label these. It's a good habit. X equals 500. That is the line. X equals 500, because I'm going to need to know that in just a minute. Which line is that that's crossing another line? All right, second one is greater than or equal to 2x. So the y-intercept is 0, and the slope is 2. Y-intercept is 0, the slope is 2. And since we counted by 500 on both of the axes, we can just go up 2, right 1. We're going up 1,000, right 500, which is still a slope of 2. We don't know where these things are going to intersect, so it's a good habit to just graph it for a while, make the line big enough until you have all 3 lines. You don't know where they're going to intersect. Got it? I'm going to label it again. This is the y equals 2x line. Y equals 2x line. And last one, well, there's 2 more, sorry. Starts at 5,100. I'm going to do the best I can with 5,100. I'm going to go to the 5,000 mark and go up just a little bit. And then I'm going to go down 1, right 1, staying on that little up just a little bit. Down 1, right 1. Down 1, right 1. you should end up at 5100 on the x-axis when your slope's -1. Okay. And one more line, y equals 0, aka the x-axis, y equals 0, aka the x-axis. All right, now the shading comes in. We got a lot of options for shading. So take them and one by one. I forgot to label my line, sorry. This is the line x plus y equals 5100, and this is the line y equals 0. I almost forgot to do that. All right, so we're shading to the right of 500. To the right of 500, we're shading above y equals 2x. That's got us down to two options. Right of 500, above 2x, our answer is either in here or it's in here. Either bounded or unbounded. The next line, the y is less than or equal to negative x plus 5100 says shade below, so we're in the triangle. All right, now I'm going to call these points point 1, point 2, and point 3 for a reason. What two lines are crossing at point 1? I can't see the answer on the graph because it's kind of not at a nice perfect spot, but what two lines are crossing in point 1? The y equals 2x line and the x plus y equals 5100 line, right? If you go back to your bell work, that was the first point we found using elimination. Second point, I think you're probably going to notice a pattern here. Point 2 is the intersection of x equals 500 and y equals 2x. If you look at your bell work, that's the second point we found. And then finally, the third, you get the picture, right? If they're obvious, which I think the point number 2 is pretty obvious, it's 500, 1000. That's solving it by graphing. That's learning target 7. You don't have to pull out elimination to figure that out, right? But for point 1, you'd need elimination to figure it out. All right, put them on your table, which you're going to have to make on your graph paper. Put the vertices on your table. They are 1700, 3400, 500, 1000, 500, 4600. Your profit function, we already wrote that. It's up here. The function is 10x plus 15y. 10x plus 15y. And we're almost finished, right? We're to that finishing point to find the maximum profit. Plug these in and see what happens. Your maximum will be one of the vertices. So plug them into the function. Your maximum will occur at one of the vertices. All right. I'll save you the calculator punches if you'd like. I've already got those numbers. When you plug in the first point, 1700, 3400, you get a profit of $68,000. When you plug in the second point, you get a profit of $20,000. And last, when you plug in the last point, 500, 4600, you get $74,000. So what should the CFSB do? If they want twice as many public attending their games, so they want some students but more public, they want at least 500 students, they want to keep it under 5,100 because that's all that will fit, how many people should they try to sell tickets to make the most money? They should sell 500 student tickets and 4,600 public. and they'll make a profit of 74 grand. That's the final answer, right? The maximum profit is 74,000. That answers the first question. And then at what, how did I word it? Now that was the first question, is how many student and public tickets should be sold? 500 student, 4,600 public. All right, I'm going to stop the video. That's the first problem.